Hi, everybody. My name is Nelson Araujo, and I'm a software engineer at Google.
Hi, Cody Herriges, business development manager, and do a lot of stuff with cloud.
So the goal of this presentation is to give you a glimpse of how easy it is to get started with the cloud and to migrate your workloads from on-premise to the cloud. And we are going to do that, everything with Puppet, of course.
Pretty demo-focused talk, so we're probably not going to be chatting too much.
Yeah, and also we said we're going to do everything in 10 minutes, so we don't have time also to talk. So it'll be like, have to be hands-on. All right, so before we get started, a quick word from the sponsors. So what's Google Cloud Platform? For the ones that are not familiar with, is Google's offering of compute resources, data analytics, and other services that will help you be more productive doing your operations, because part of the management gets done by Google, and the technology that Google uses can also be used by you. I'm not going to spend too much time in the market spiel, don't worry, but I only want to highlight a few important details, which is once you're using Google, we are building the systems so in a way that can make you really more productive. And for that, we have data centers all around the world, and we're also trying to be not just faster and more reliable, but also cost-effective. So Google just introduced recently a per-second billing. So if you have resources, we will charge for the second. You're not going to round up the hour and say, hey, you use 5 minutes, I'm going to charge an hour for that. If you use 7 seconds of compute, you're going to charge you 7 seconds, not 8. So that allows you to run workloads that are usually in bursts. Let's say a MapReduce that you have, let's say, 1,000 nodes in a few minutes, then you are not going to be worried about, oh my goodness, now I have to make sure they round up correctly, otherwise I have a huge bill at the end. And another thing is important is the sustained discounts. The more you use, the cheaper it gets. So if you keep bringing machines up and down, at the end they're going to be all put together as one machine or many machines, it doesn't matter. At the end, the core hours are stitched together, and you pay the discounts. You get the discounts for that. So to learn more, like I said, this is not a marketing talk, it's a demo talk. Please go to cloud.google.com or reach out to us at the booth later. And so you can get started. So there are many ways you can get started, and a good way is try before you buy. So if you sign up for the account, you get a $300 credit. If you are in the conference, you can reach out to us at the booth or at the end of the talk. We can get you another $200 coupon so you can start experimenting. If you are a startup, the Google has a program for startups that can get you access to resources, engineering, and credits so you can get your workloads. And if you use this code or that link, that will be also at the end of the talk, you can get another 200, just to make sure you use and are convinced before you switch. All right, so now let's get to what we're here for.
All right, so the entire module, most of what we're doing is based off demo using Puppet modules that Google's been working on for several months, a couple years.
Years?
Yeah. And it's kind of have a goal of covering the entire set of services that are available in GCP. And we're marching towards it quickly with a number of modules every quarter. So just about a month ago, we released the ones on the top, and the ones on the bottom were released during Contributor Summit. And so we'll keep kind of going ahead. So the big reason for this is the industry is transitioning from the idea of having to manage services as services on a machine or software as packages. We still manage all of those kind of applications, and there's still components of them that make that up. But those actual resources that you are managing are transitioning from package file service to virtual machine, container cluster, and database services. So even though we have all these different primitives now, they still are there to accomplish the same goal, which is to manage and model your application. We just end up calling a lot of this stuff infrastructure. So that's why the partnership's really important, and the investment in this and the public community and working together with Google is just to make sure that you guys all have these tools to make that transformation easily internally.
And whoever was here last PuppetConf, not here in San Diego, we announced the first preview of those. And our goal is to create the set of tools for Puppet. And the tools will actually feel, if you start using them, cohesive and comprehensive, because they are all done by the Google team. So the community helps, but if you when we let the community drive, they drift in terms of style or in terms of feature coverage. Our goal is to cover absolutely everything. So we are nearly 100% coverage of all GC, Google Compute Engine. So we released the version 0.2 of the modules that does all things load and balance, which we're going to use today, of course. The container engine 0.2 can integrate with the famous Garage Kubernetes module. So if you're using Kubernetes today, you can very easily connect a container engine. We had a talk that just finished that Mandy was showing that, and you can also check that out later in the recording.
So we were going down a path of trying to figure out what we were going to do for PuppetConf, and I got my hands on Bolt a few weeks ago, and I kind of went to Nelson. I was like, let's do this. Let's see how many we can get done by PuppetConf. So as of the day of the keynote yesterday, I think the Google modules had half of the tasks that were up there. And so we pushed really hard to get these in here. They serve purposes like just giving you a couple utilities to actually facilitate your plans for doing workflows. They also do a couple of things where the Google API just does not fit very well into Puppet's model. There's like lack of item potency, or maybe it's item potent, but there's no reason you would ever want to do it every time in a Puppet run. And so those are all available there. We have 5 of them up there now, and we'll keep pushing and finding more.
Yeah, just like a real example is one thing that's not idempotent is restarting a machine. In a Puppet manifest, I can define, please ensure my machine is present, it's running, is healthy, etc. But if for some reason some process needs to restart the machine, there is no good way in Puppet to say ensure restart it. But if I run that again, I'm going to restart again, it's not idempotent, it doesn't fit well in the model. So for that, for example, we have a restart task into the compute. It's a Bolt task that you can invoke from Bolt and from Puppet from different places, like you can choose.
That specific task has a special place in my heart because it's the cloud equivalent of going and pushing the button on a piece of hardware and like holding there until a hard resets, which every sysadmin has probably ever done in their life, if you're not a teenager. Sorry.
All right, so reminder, we are on a clock here. So what we are going to do is, because it will take probably a minute or two for the things to come up, we are going to give you a quick overview of what you're going to see later, run the scripts, explain what they are going to do, and then go back and see if it really happened, hopefully. OK, so let's get started. So here's the environment we have. Our environment right now is a clean project. The idea is from nothing to production. We have a Puppet Enterprise installed. It did not need to be in this project. It can be anywhere in the internet, it can be on-premise, as long as the machines can reach the Puppet Enterprise or the Puppet open source, depending which one you're using. It doesn't matter where it is. This, for the convenience of this, we put it over here so we can click on it and see what's happening. But it's not a requirement. So this project could be even blanker than it is right now. And what I'm going to do is I'm going to refresh all these tabs. I'm not going to go through what they do. We're going to do that after we understand what they do. You see this site's not working. And then we are going to run some.
Yep. So we had all this stuff originally in just some Puppet manifests, and kind of for completion, and I have a manager title, but I'm also a developer and a sysadmin. I literally converted these to bullet tasks and plans this morning, or late last night, because I decided I didn't want to go out and do anything. And then we tweaked them this morning. The process of going from Puppet to Bolt is fantastically simple and quick.
Yeah, that's actually growing on me. I started doing that too. So. I guess that's it. Yeah.
Yeah.
Can you guys see okay the screen? Yeah. Okay. So what's happening here? We are running a Bolt task to set up in our application on the Google Cloud. And again, we're going to let this run, and we're going to back to the slide, so explain what's happening behind the scenes. Then we're going to look at the code, and then come back.
So there's a couple things that Bolt allows us to do as part of that run, which a lot of these cloud processes sometimes would take multiple Puppet runs. So what we've actually done is orchestrated that process by converting these things into Puppet-based Bolt tasks, so that we can get all the information and kind of set up DNS and instances all in one kind of go.
Yeah, the example that made the Bolt test very enticing here is, for me to set my DNS upstream, I need to know the IP address that I need to put it over there. Because, again, I don't have anything before, and I'm not going to hard code anything in my manifest. But the IP address are dynamic allocated as I run. So until I run for the first time and get my IP addresses, well, I don't have the IP address to go put in my manifest to set the DNS, which we also using Puppet for. So the Bolt task allow me to do a first round of runs and get the infrastructure up, and do a second round of runs and get the DNS set up, so my app is actually be available online. There are a few prerequisites here. So obviously, I need a blank project, and it's important if you're doing that. Everything that we are doing here will be available on GitHub, so you can actually replay this demo yourself. Everything we are doing here will be available on GitHub. One important thing you have to make sure is you enable the correct APIs, because in the beginning, everything is disabled by default. So in this case, we are using DNS and compute. So you go to the necessary places and set them up. And we created an empty DNS zone because you still need to sync with your parent DNS. I didn't want to go to that for the sake of time, but the zone is blank. If my zone is also, parent zone is also at Google, I can update the parent zone also as part of this process. And we are running that machine, we're calling here the admin machine, that can be run anywhere, even in your laptop or in your CI/CD. Doesn't matter where you run that, because all of that goes to the cloud and will operate properly. So here's what our application is. It's a web application written in PHP, uses Apaches, and as the application progresses, you have dynamic things loading, like images, panels, and other things, like straight out of JAX applications. So there are a few steps. This step we already did, which is basically you need authentic authorization to access the cloud resources. For that, we use what you are calling the service accounts. In this case, once I go as admin, I download a JSON file with the keys and credentials, everything else. I put that key in that machine that Cody just ran. And I got all the Google modules with a single Puppet module installed. So if you go to any Puppet, agent, server, enterprise, OSS, doesn't matter, that command works and brings all the Google code for you. If you want to cherry pick which one, you can go to the Forge and pick, I want just compute. You install the Google G Compute instead and bring just compute. But if you say Google Cloud, it brings everything up for you. And we are going to get our application. But apparently I was too typey. Let's not read that, so let's see this visually. So it's a standard application. So I will allocate a static IP address for my application. I will record that static IP into the DNS, so you can access yourself. So if you don't believe, you can actually, I'll give you the link in a second, you can actually try in your laptops as we do. And basically, the www of my application is served by my machine itself, right? Just like if you have something on-premise on your own data center, like nothing special, and Puppet is setting up that application for me. So here, I'm starting from scratch. Like I boot a blank CentOS machine and do everything with Puppet. If time is sensitive, we will show you later how we can speed it up this process and it makes it work. All right, so let's see what we got there so far. Oops, wrong window. Okay. So in the beginning, I had, oh, let's explain first what's happening over here, right? So in my profile module, we have the plan to bring my app up, which, like Cody said, we are running 2 tasks, which is actually one task to bring the whole infrastructure up, the machine setting up the connection with Puppet and bring the app up to date, and another one to run the DNS. And because I can use this for testing purposes, I have the reverse, which is basically all the manifests ensure absent instead of ensuring present, and I just get rid of everything. So that's very convenient if I want to deploy this in a testing environment. I just need to change my project name to another project. I do up. Once I'm done, I do down, and I can use Bolt to do that.
So before we go, if you guys haven't seen Bolt or Puppet tasks yet, you'll notice the local hosts up there. It's just that Bolt with launch did not have a local connector for executing stuff. So we are SSHing back to ourselves to run the task. That's going to go away eventually. But for right now, that is a thing that you have to do.
And so let's take a look at what it takes to actually bring that environment up. So in this case,
yeah. So the primary thing to highlight, this is a vanilla Puppet manifest. All right. This is just things that people have been running with Puppet Apply for ages. You can actually use Puppet Apply as a script interpreter. Just add it to the shebang of a top of a manifest, and you've predominantly have just instantly created yourself a Bolt task. And as long as you name it right and put it inside a module, Bolt's going to load it and run it for you appropriately. The other special thing you see here is we are actually diving down into Ruby a little bit to be able to pull environment variables that are being fed into this manifest by Bolt. And that's what you see as credential equals that are up at the top. You can also do this through standard in, and there's a function out there to do that. We just kind of hacked this up real quick.
Yeah, so before we learned about Bolt to start working, this was a standard Puppet apply. So if instead of Bolt you go and say Puppet apply this PP file, you get absolutely the same behavior. And I was using facts instead of the Bolt environment variables to do so. Before I would like factor underscore something equals and then Puppet apply, and that's all I needed. Yeah.
So Bolt just kind of gives you, for certain aspects, certain uses like this, a better CLI that kind of makes these one-off scripts more maintainable.
Yeah, so let's dive down a little bit over here so we can see if this really worked, which we hope it will. So all the Google modules uses this unified credential mechanism. In this case, I'm setting up using service accounts. And although my service account is owner and admin on everything, I still want to do like Unix style. I can drop myself to nobody or to a specific account. So I'm limiting what this account can do during this run. So in this case, this account, although, like I said, can be super powerful, can only access compute and can only access DNS. So if this script accidentally try to do storage, will fail. The thing is, this is not a security against a hacker, because my account is already administrator, already have the privilege. This is so I can make my scripts more robust and I don't accidentally destroy stuff. So the security is guaranteed by the service account, not by this. This is just one step further. The same way we run as root and in Apache drop to some user to not allow root to destroy everything gets compromised. Same deal here. So we have defined the basics, like zones, regions, things we need. So I'm going to skip so we can go see what we actually use for this. So in the gcompute address, I'm allocating the static IP I needed. And I gave that IP the name, like in a true Puppet style, an ID. So this resource has an ID that we're going to be used later. If we look at the machine I created, sorry, will be an Ubuntu machine. If you're running tests, don't forget to set auto-delete to true so you don't leave disks behind and litter your project. And we set some metadata to connect the machines to the Puppet Enterprise. So we have a startup script that brings it up the certificate, because in my Puppet Enterprise, it has a self-signed certificate. So if you are using a public certificate, you don't need to do that. Or if your machine is preset. Again, my machine is blank. CentralOS will not trust this machine I just installed and say, hey, here's a certificate for a domain that I don't understand. Those are things you can do later to make this simpler if you want. So my machine will have access to the internet. That's where I use the static IP that we talked before. So here I can say that's the IP the machine will get. And because I decided to put my startup script and my files in storage, that's why I need storage. This machine will have read-only access to storage. You cannot write anything, you can only read from it. And I want this machine to have port 80 open, so I enable the tag HTTP server that is defined by the firewall. You can have your own networking, everything that does that. So, and that's basically it. I Puppet apply this, and let's see what happened. So if we go back here, now I have a new machine. So if we look at this machine here, has my one core. It has an external IP that points to this IP. You don't have to type, it will be a link later for that. Here are my metadata at the bottom, which connects to my Puppet Enterprise. So if I go back here, I see again the IP just allocated for me by the Google Cloud. Again, it was dynamic, but I don't care because I connect the resources using Puppet. Say, use whatever IP address the other Puppet resource just created. I don't need to know, I don't need to change that file. The file can be read-only for all practical purposes.
One of the features we have in the modules is a set of functions that can use GCP as a source for extracting data.
So my DNS zone is now updated. So if you go to www.puppetconf17.cloudnativeapp.com, you can see the app running right now.
One of the things Nelson does with all the demos is we end up using public IPs with open firewalls. So these things, you can go to them throughout the demo.
Yeah, so if I refresh here, I have my first app here running, right? So this was set up using Puppet. So, and that's basically all it took for me to bring it up. So we can go to see what happened inside the Puppet Enterprise, but my app that was running on-premise now is running on the cloud. So if I had a single-tenant app running somewhere else, I'm done. So I don't know how long it took. Hopefully that less than 10 minutes. And most of those scripts that you saw, we ship all those scripts together with the modules, and we have ample documentation. They are all executable. So if you copy any script from the docs, they will run, because you run them before you put on the doc. The doc cannot manually read, it's automatic. So you get the script and compile the doc and push to GitHub or into Forge. So most of that was actually written straight from the samples. And basically, that's all it took for me. So let's take a look at what happened here, right? So I'll let Cody take it from.
So through all that kind of infrastructure-based Puppet code, we ended up with one node here. And it got Puppet installed on it, and then wired up to our master, which has some classification already set up to automatically pull in the following classes. And like Nelson said, this is not super complicated code to get things going. These are most predominantly, this is kind of the only thing that did any other work outside of some pretty vanilla modules. And we can see what happened there through this report. And there's a ton of stuff in here, and I'm not going to go through all of it. But if you need to understand how this thing was set up and what events occurred to actually get you to the running website, this is where you'd find that, and all that information should be available. So.
Yeah, and one important thing here is when I'm doing this migration, assuming I'm the ops guy, I don't need to know how the developers put this Puppet Enterprise together. I can assume it works, and given a blank machine, you can set it up correctly, and that's all it takes, right? So my scripts didn't even know what classification had. Say, hey, Puppet, come here and fix for me whatever you need to fix. Bring the machine into the state, which actually Puppet does best.
So
right?
Now we'll kind of start moving into other portions of the demo. And Nelson's going to upgrade the app here as well. Kind of from here on out, nothing really changes. So the demo itself should get a bit quicker. We don't have a super lot more to explain. The Puppet code just gets a little bit more complicated.
Exactly. A little? Yes, just a little. Just a joke. So because the machine is now hooked with Puppet, I can do things Puppet style. So if I need to upgrade my application has this variable that, given that, selects different classes, which again is on GitHub. We can look at that offline later.
And so now that Nelson's committed the version change, we can actually just hop in and run Puppet from here as well.
Yeah, before we do that, let me refresh this one more time to make sure it is the same. Yeah, so the date and time is there. Yeah, sorry, it's in GMC time. And now we can run Puppet. And Puppet will do what Puppet does. You guys already know. Go there and make sure the new version 2 is set correct and everything brings it back to compliance, right? This should just take a few seconds. And now the run is complete. If I go back to my app, again, you can try it by yourself. Oops, too big. So I have my app version 2 running. So now, again, as part of setting up an application, bring it to the cloud, we were done like 5 minutes ago. So now what I want to do is make this robust and scalable, because moving to the cloud has the benefit of simplifying my operations, but also brings the benefit of making this more robust, reliable, and so on and so forth. So let's go back to our slides so we can see what's coming next for us. OK, it's time to do more things. OK. Yes, back here. So now what we're going to do is we are going to bring it up a load and balance application. And again, I'm going to, if we go just one more refresh here before we do anything, there are no load balancer in the system today. And because I now have an application in production and I'm bringing a new application up, I prefer to work in a staging environment separate so the users don't see why I'm actually preparing this new version. So I have a staging site, which obviously doesn't exist because it doesn't deploy yet, where I can experiment with my new application until I feel it's ready to shift my application to production, right? So now I have, let's say, stage 1 complete, user using my application. Let's go to the next level. So now let's go and do, oh, what is it? Oh, there it is. All right.
All right, so I didn't really explain kind of the bulk command line last time, but that's partially because it's ridiculously simple. So we do have, we're running a plan here as opposed to a task because we've strung multiple tasks together. So that's what bulk plan run actually goes. Since these are in modules, you just use a very familiar kind of Puppet-based syntax for fully qualified references to classes. But in this case, we're referring to tasks. And so we're in the profile module, and we want to run the LNB app plan.
And the plan looks very similar to the other plan, but now I'm invoking different Puppet manifests, which will set up new objects to make this work, which again, we are going to explain what they are. It
actually pretty much looks exactly the same, save one variable. We just split it out so that it was super obvious for the demo.
Yeah, and this is useful because, like I said, even after, if you get familiar with this, and we released a few days ago the Spanner integration. Now we can configure a Spanner, Google Spanner using Puppet. If you go read the documentation, it's like, whatever, I just need to know the types. I know exactly how it works. It works exactly like the compute, exactly like the DNS, or anyone else. So there will be no new learning curve. There will be like, oh, now the credential has to be in an environment variable or in that conf file that the other guy put in a different location. It's all the same. It's all homogeneous. So it makes it easier for ramping up new people when you go into training and make them better. Right? So to make them scale, we need now new toys, right? We need to make sure I have multiple machines now because machines can die, can go out, can have failures. we also need to split traffic between them because you don't want to overload your machine. If you can run faster because you have now, let's say, 10, 100 machines serving, why stress the machine and make it run slower? Just distribute your load accordingly. So for that, we are going to introduce in our application load imbalancing.
Yeah. And I think originally we thought that the bolt run was going to take longer, so it was going to run while we talked about this slide, but I noticed it's actually already done.
Yeah, but the machines are being created. Yeah, we are going back to that.
Yep.
But again, we don't have to read this part here, so let's see what happened. So this was our version 1 application, right? So our www being served. So what I want to do now is make it way more complicated. No, complex, not complicated, because it's still very easy to do. You just have more pieces. So what happens now? So my application will be deployed in various machines. And because I want scaling up and down, I need to teach the Google Cloud how to bring new machines up. So for that, we are using what we are calling the instance template on the top right, which is basically a blueprint of how a new machine looks like. And if you look, as we're going to look into the template in a minute, dramatically just look like a regular machine. It's just as a blueprint where things you can parameterize now. For example, machines will have different names because they are dynamic. So you tell how you want them to be called, or things like that. But the core of the original configuration, how to connect to Puppet, how to set up memory, network, is all the same. Actually, you can even copy and paste into the other one. Just I was VI, just indent by 2 and wrap it up. So now we have a problem, right? So we had before my DNS pointing to that machine, now have many machines. One could try to use a round-robin DNS, but that solution is not fault tolerant. And so what do? We are going to move our www to the Google load balancer. So that's a service that Google uses to route anything Google, YouTube, search, everything else, you know, Maps, Gmail. And you're going to be using the same infrastructure. We don't have any infrastructure for us. That's nice, and the second class for you. It's actually it hits the same massively load and balance because that's also balanced and worldwide. So yeah, go back a second.
Back one. Here we go.
So what happens now is we need to make sure now once that request hits that point, we can actually hit our machines. So that's why I introduced these new types. So a forwarding rule is basically a way to teach Google, say, once I get this request that looks like this, send it to those machines or services over there. It's a pure like that. And I give my forwarding rule an static IP address, so I can register that IP address to the DNS. So basically, my DNS now has a pointer to the load and balance, and say, from that point on, Google will take through. So now, when the machine, the request reaches the target pool, which is this unit that coordinates, the target pool you send to the instance group. The managed instance group is the resource that scales your machines up and down. You can specify any number there, or you can say an auto-scaling policy, say, hey, if the machines hit 80% load, bring more machines up. If they go to 10% load, take them down. So you can configure all that in the instance group. It can be very sophisticated. For this demo, it's just a fixed number, which is actually 10. But like I said, the machines can go bad or can misbehave in some way. So the way we track that is with a health check. A health check, which we also define, I define the criteria of how I know my machine is healthy. So in my example, I have a URI that I ask in my application, say, status. Status has to return the word OK. If my machine, my app is misbehaving, I can return error of 500 or a string error, whatever. And the health check say, you're not compliant for some reason. And we'll tell the target pool to say, don't send traffic to the machine anymore until we can correct, or user can correct or something. So now, if machines fall off for some reason, you can take them out while we investigate, and the system continues to run. Right? So let's see how that actually played out. So if you go back here to my networking services, I'm going to look at the manifest in a second. So I'm going to the advanced so I can show you all those things. So sorry, back here. So I defined my template, which has my blueprint. I have a group of machines that has here 10 instances, and I can see they are all here. And I will set up a target pool that will say, hey, the target pool will use that group. So as you see here, the greens there is because the health check is reporting that the machines are healthy. So if we'll go back to Puppet, we can see that all the machines came, registered themselves, got configured. And now if we go and see our staging, there it is. And if I keep refreshing, you can see the hello from changed like the last 4. But it's kind of a boring hello world application, so let's make this a little better. So if we go back here, I have an old school application. That will show us what's happening under the covers. So basically here, my app is leaking out. Don't do that at home. The name of the machine is actually running on. You don't do that. And the version of the application is actually running. So you see at the bottom my workers, they are running version 2. At the top, I have a summary. All my applications running version 2. So because I want my new and sophisticated application, I'm going to, again, use Puppet for that. And we are going to change the version. It's here, right? To 3. Can you run a job for these guys?
Yeah, go ahead.
Okay.
So quick.
All right. So what I'm going to do is, because I want to run this right now, I'm going to say, hey, let's run the job right now. And I'm going to select all my nodes. You can use a query for that as well, right? But for now, I'm going to run on them all. And we will see that I'm going to upgrade my www application to version 3, but it will behave differently from my version 2. Because in my version 3, my single tenant application, I only have one node. Right, so let's see here. So if you go back to my little target there, you see that version 3 now came up. Version 2 rates is slowing down, and once Puppet finishes them off, version 2 will stop. So as you see there is no more version 2. And what this little app is doing is just getting requests to the load and balance. Tell me the version that you ran this thing on. Like I said, it's something you don't do just for debugging purpose, it works well. So if you go back to my www application, it's something like this. So basically, I have this panel that I can get many requests. And because I only have one application, they come from the same machine. And I'm using color to make the machine more obvious. On the same time, if I go to my load and balanced application, each color is, again, from a different machine. We calculate the color on the fly. I don't know what color is which machine.
So, yeah, remember, production right now is just that single machine, that first bolt run we did. And so staging that Nelson's currently looking at is the second bolt run that we did, which brought up a whole lot more machines behind a load balancer.
Yeah, and I want to experiment with crashing this up before I put it to production. So for my convenience, I put this debug here, where I can SSH to a machine. So let's pick the red machine here. Seems to be popular. And I'm going to crash that one up. So I can easily SSH to the machine, and I will just stop Apache, which will obviously make my app crash. What I'm doing right now is I'm putting these show failures here, which I make my app show you what's happening behind the scenes. Normally, a production app will also not have that. You don't want clients to see failure. Everything is still running. And if I go here as admin and I stop Apache, you're going to start seeing that the next refreshes may have some crashes. Come on. So the little failure there was the machine trying to respond to that was not there, and my app will retry. Obviously, I'm stopping here so you can see that. Normally, my client app could retry to that. But what happened behind the scene is Google will detect that machine got bad, and will take it out of the load and balance. As you see, there are no failures anymore. So for this demo, I made the health check be very lenient. So that's why these things took longer to detect. You can coordinate based on how much failure you can tolerate, how much resource you have, how aggressive is the health check, how lenient. All of those are parameters. In my case, it has to fail for 10 consecutive seconds, up to 25 seconds before Google say, and take it out. So if you go back to that little list we have and refresh, we are going to see that one of the machines are now considered bad. Right? So, but Google took it out. Now I know I have to do something, but the customer is not affected by that. And because now I'm happy with this application, my www, again, is still unaffected, we are going to flip to production that application. Right? So I think it's ready for prime time, I hope.
Yeah, it should be. So we quick kind of demo of just parameterizing bolt tasks. So we add one parameter to this, and we just called it production, and we say true. This is the same bolt task that we already used. Oh, sorry. This is the same bolt task we used to set up the load balancing application. There's just one switch inside there. We have like 3.5 minutes, so we can maybe go look at it or just answer questions.
Yeah, we would probably take the DNS like 10, 15 seconds
to propagate.
Propagate.
Yep.
Again, I'm using a very aggressive DNS here. Normally, you don't make your thing reload, expire after 1 second or 5 seconds. So again, for demo purposes, but you shouldn't do that. You probably should put something more.
So yeah, you see it here down at the bottom. We actually have a resource that says www. It's turned from our original IP to the new .175.
And if the DNS helps us here, if I keep refreshing this, eventually my new application will be refreshed with that. OK, so a quick peek on what we ran there. Like I said, it looks actually is exactly the same as GIF. We showed you most of that is the same. The difference here is I created that template that describes the model. And like I said, everything that's indented by 2 now looks a lot like the original instance. And that gave me the blueprint how to build new machines. I also created a firewall rule to allow the health check, Google to probe my machine for health check, because by default everything's blocked. So I use the firewall rule for that. I create my health check. I said the request path is status, so I can actually, you can be anything you want. It can be any kind of test you want. So for me, my app also responds to status. And at the bottom here, I have my instance group manager with 10 machines. Right? So all of that was stitched together by that. And hopefully, if you refresh here now, my www, I have my application running. Right? So now it's in production. And if I want to deploy this on CI/CD, I just did actually. Staging was my CI environment for testing purposes. I don't have to affect production. I can affect production whenever I want. Right? So
in classic fashion, Nelson could go back to that original node and run Puppet, and it would join the load balancer again. OK, so what else you can do going forward? Of course, we covered as much as we could in this short amount of time. But you can make this way more sophisticated. One of the things we did, which is important to emphasize, is we start from blank, which means I went to Ubuntu and did an update. I went and installed the agent. I went and downloaded all the profiles, from the ground up. If deployment time, cutting deployment time is something you need, there are many tools and tricks you can play. The most standard is you create an image. So that machine that kind of looks OK, I can easily make that into an image template in Google and start deploying from there. Then you can use a Puppet to bring from that point to your correct point, which you cut up a lot of deployment time. One important thing is don't forget to remove the machine identity, because you don't want the machine to keep telling Puppet is the same machine when you load and balance, right? So when I start from scratch, use the machine name, but if you already ran Puppet, you may have your machine identity set, so you need to set that. And you can do other things. You can make like HTTPS load and balance. So Google provides that for you. There is only one little caveat here. Good, they can read the caveat. Good.
which is the modules are on Puppet Forge today. They are not 100% able to do all the load and balancer. They can do like 80%, but in the next release, we are going to catch up to that and make you do absolutely everything I did here in an HTTPS format fashion. And all of that to be available on GitHub. So if you want to access all the code we ran, all the plans, everything else, we are going to add some documentation later explaining everything we did here. But all the code is already there today. You can start actually doing your own CI from these as well.
Yep. And if you want a coupon code and you haven't got one yet, Alex will have them back in the room, or they're on a table back there already. Or come ask Nelson and I.
Yeah, and we will be available at the booth, so if you want to dive in more details of anything we did or any other problem you have that may not be addressed here, just let us know. I guess we're not out of time, sorry. Questions later.
Thank you.